Good morning, dear students. In the last class, we have started the concept that is regarding the interference. We can define the term interference. When two or more waves superpose on each other, there will be a variation in the distribution of energy. Okay. So, in order to obtain the interference phenomenon, the sources should be coherent. Okay. Two sources are said to be coherent only if the waves are of same amplitude, same frequency, same wavelength with a constant phase difference. Okay. So here in the previous class I have considered an example of a zero part difference. Okay. Once again just I will start from there only. Two sources S1 and S2. In that first example I have considered part difference of 0. S1P is equal to S2P. So exactly center. Okay. It's the point P. So the displacement of the particle from S1 to P, from S2 to P, the displacement value will be same. That is, if Y1 is the displacement of source S1, mathematically I can write Y1 is equal to A cos omega t, where A is the amplitude of the wave. Similarly, what is Y2 here? Y2 is equal to A cos omega t. Okay. In the previous class I have considered an example, that is S1P is equal to 4 lambda, S2P is also equal to 4 lambda. You know that one complete cycle, this one is lambda, nothing but it will be 2 pi. Okay. So 1, 2, 3, 4. Similarly 1, 2, 3, 4. Okay. Phase difference is 0. Okay. Y is equal to, what about the resultant displacement? Y is equal to Y1 plus Y2. I will get 2A cos omega t. So here initial intensity of the individual wave I0 is equal to A square. So this is the resultant amplitude value. So I is equal to 2A whole square 4A square, nothing but 4 I0. In this case, if part difference is 0, what's the value? What about the intensity? Intensity will be maximum. Intensity is maximum means which type of superposition or interference it will be? It will be constructive superposition or the constructive interference. Okay. It was the one case. I is maximum. Okay. Next, next one more example. 6, 7. It takes 2 cycles, more 2 cycles in order to reach the point Q, but the phase is same. See here, finishing this value. Trough, here also it is trough. Same phase difference, okay? Same phase difference, okay? You know that phase difference is equal to what? Phase difference equal to what? 2 pi by lambda into path difference. You know this relation which you have already studied in your first few class. What's that? Phase difference is equal to 2 pi by lambda into path difference. In this case, the path difference is how much? Path difference is of 2 lambda. Okay? Path difference is of 2 lambda. If value is 2 pi by lambda into 2 lambda, the phase difference is how much? 4 pi. Okay, phase difference is how much? 4 pi. Next, I write the equation. Let y1 be the displacement of the source from S1 to Q. That is y1 is equal to a cos omega t. Okay. Since there is extra phase difference of 4 pi, in order to reach the value from S2 to Q, I have to differ that value from the first equation. So I can write the value y2 is equal to a cos omega t minus 4 pi. Okay, a cos omega t minus 4 pi. You know the standard value of this if in terms of pi, it will be nothing but a cos omega t. will be 5 pi. Okay, phase difference will be of 5 pi minus 5 pi. Okay, you can substitute in the formula, you get the same thing. That is 2 pi by lambda into minus of 2.5. Minus 2.5 is nothing but 5 by 2. 2 cancels, remaining is 5 pi. Okay, phase difference is minus 5 pi. So mathematically, the displacement of the source from S1 to R is y is equal to a cos omega t. Okay, next the displacement of the source from y2 is how much? The cycle of 5 pi, phase difference of 5 pi, to that value we should add. So cos omega t plus 5 pi, you know the standard trigonometric variation. So cos plus and pi, it is nothing but minus cos. Okay, so value is how much? Minus a cos omega t. Generally, you can see here the displacement, resultant displacement y is equal to y1 plus y2. A cos omega t minus a cos omega t. Okay, a cos omega t minus a cos omega t is how much? It will be 0. Okay, part difference is negative or odd multiple of lambda. Okay, odd multiple of lambda. In that case, what you will get? The interference will be of destructive phenomenon. Okay, destructive pattern. So in the first S1p and S2p, part difference 0, it will be in same phase and 0 part difference. So there is a constant phase difference. Prof of one way superpose on prof of another way, constant phase difference, or crest of one way will be superpose on crest of another way. So in the third example, third case which I consider, it will be out of phase. Okay, so generally we have obtained the condition. There is one standard derivation. So if there is a phase difference of pi, using that derivation you have to obtain the condition of the constructive interference and the destructive interference. Okay, so whenever there is a, or we can say generally, whenever there is a constant phase difference or the constant path difference or 0 part difference, which type of phenomenon occurs? It will be of constructive interference. Okay, if it is out of phase, the interference will be of destructive pattern. Okay, let's derive that. Okay, so before deriving that, let's see the interference experimental setup. First foremost, setup of the Young's double slit experiment. Okay, which was performed by the, demonstrated by the Thomas Young in the 1801. Okay, the initial setup of the interference, that is Young's double slit experiment. Young's double slit experiment. Okay, so first foremost experiment, there are some, in this case the source of light was sunlight. Okay, there is a cardboard shape with a pinhole. Okay, after certain distance, one more sheet was obtained, considered with a 2 pinhole. These 2 pinhole act as a 2 coherent source. Finally, the pattern of alternate fringes, bright and dark fringes, the wavefront pattern, dark and bright band, were obtained on the wavefront. Okay. So it will be a spherical wavefront. Okay. So the distance from, if it is A and B, it will be equidistant. S to A and S to B will be equidistant. This source wavefront once again passes through A and B. Wavefront once again passes through A and B. A and B once again pinhole. So once again the spherical wavefront comes here. Okay. Alternative bright and dark bands are obtained. It has been seen that exactly center of that the intensity will be maximum, which is nothing but central bright fringe we will say. Okay. Next, somewhere here we will get the alternative dark band. Okay, dark fringe. Once again, next bright. First bright fringe on both the sides. Exactly center, the intensity will be maximum, and next to that dark, and once again next to that bright pattern has been obtained on that screen. Okay. Later on, the main replacement of that, the instead of sunlight as a source, what has been obtained? Monochromatic light has been obtained. Okay. Monochromatic light. You know the definition of monochromatic light of nothing but single wavelength. Okay. If the light having single wavelength, such type of light is called as a monochromatic light. So the experimental setup of this is such a way that a monochromatic light has been used as a source. Okay, there is one stand here. Next, they have considered a cardboard with a narrow slit. Okay, which is the source. After certain distance, one more cardboard has been placed, which consists of two narrow slits, which acts as the slits will be thin, interference. In the exam, so exam point of view, it's a 5 marks important derivation. Okay, so in the diagram just now I have drawn a source, monochromatic source. As in this case, A and B are the two coherent sources. There will be a part difference of pi or the phase difference of pi. Okay. So here S is the source, monochromatic source, which is equidistant from the two coherent source A and B. Given condition is that there is a phase difference of pi. Just now I have derived. Okay, just now I have derived or considered various examples. Okay, here let y1 be the displacement. Okay, y1 be the displacement of the source from S1 to S to A. Okay, sorry, if it is, let it be point P, A to P. Instead of S1 and S2, I have considered AB. So map say point P. There is a phase difference of pi. So displacement of the source from A to P, I can write y1 is equal to A cos omega t. Y1 is equal to how much? A cos omega t. Y2 is equal to, where Y2 is the displacement from B to P with the phase difference pi. Y2 is equal to A cos omega t plus pi. A cos omega t plus pi. Okay. So the resultant displacement is how much? Y is equal to Y1 plus Y2. What I will write? A cos omega t plus A cos omega t plus pi. Okay. In both terms, what is the constant term here? Amplitude is constant. If I take A cos omega t plus cos omega t plus pi. Okay, it's the form. You know that cos A plus B as standard form. You know this relation. Okay, cos A plus cos B. What is cos A plus cos B? It is 2 times the cos of A plus B by 2 into cos of